morning. The inverse of function exists. The inverse of function exists if function under consideration is 1, 1 and onto both. We already studied in this relation and function chapter that function is having two sets which are called domain and codomain, and the elements of codomain are called range. Here this 1, 1 and onto both functions are essential for this inverse function. Suppose this is my domain and this is my codomain. So this is 1, 2, 3, 4, the elements of domain, and the elements of codomain are A, B, C, D. Then 1 is image of this B, 2 is image C, and 3 is image A, and D is this image D. And this is actually represented by this function. This is maybe a sort of example of this 1, 1 and onto function. Now if the function is, or we can say the inverse of function, the inverse of function is a trigonometric function, then it is called inverse trigonometric function. How can I represent this inverse trigonometric function? Suppose sine theta is equal to x, so theta is equal to sine inverse x. Here the domain and codomain are very important for this function as well as inverse function. First of all, we discuss briefly about this trigonometric functions. What are the domain and range? So the domain and range of trigonometric function are as follows. Suppose this is your function, this is your domain, and this is your range. Suppose I am taking a function sin x. Domain and range are always, it is real numbers. Cos x is equal to r and r also, and tan x is also equal to r and r. But here in this r, we have to take some a condition that 2n plus 1 into pi by 2, where n is integer. And similarly, if I am taken as a cot x, then r is minus of n pi, where n belongs to z, and this, of course, they are all real numbers. So sec and cosec are also the same type of domain and range, and slightly change in the domain as well as this respective tan x, it is and this cot x. But what is the difference between this inverse function and inverse trigonometric functions and this trigonometric functions? Here the functions 1, 1 and onto are very important for this inverse trigonometric function. What is this functions about this trigonometric functions? briefly we can say that sin x and cos x functions are neither 1 1 nor onto. And if they are 1 1 and onto, then they are inverse functions or inverse trigonometric functions. Other elements, tan x, cot x, cosec x, sec x are only onto functions, but not your 1 1 function. So we can write here briefly that sin x and cos x are neither 1 1 nor onto. Similarly, the other trigonometric functions, means, of course, tangent, cotangent, secant, cosecant, or we can say briefly tan x, cot x, sec x, cosec x are 1 2 or onto, but not 1 1. This is about trigonometric functions, and they are generally, we can say, 1 1 and onto both are not means satisfy the conditions. Now, what's about domain and range? Of inverse trigonometric functions. Here we can say it's a function, and this is my domain, and this is range. Suppose my sine inverse x, the domain is always, remember, minus 1 to 1. Of course, in trigonometry we say domain is a real number, and here we mention with a restriction that they are closed intervals. And when they are closed intervals, then the range is also represented minus pi by 2 to pi by 2. Similarly, we can say here cos inverse x. In this cos inverse x, this is also minus 1 to 1. But here the value is 0 to pi. Why it is so? Simple. Cos 0 is equal to 1 and cos pi is equal to minus 1. Remember, our parents' functions or angles of the trigonometry, sine inverse x and cos inverse x. Sine 0 is equal to 0 and cos 0 is equal to 1, and sine 90 is equal to 1 and cos 90 is equal to 0. And what's about the tan inverse x? Tan inverse x is also, but here it is minus 1 to 1, and this is represented as minus pi by 2 to pi by 2. Here the question arises that this is closed interval, big bracket, and the small bracket is minus pi by 2 and pi by 2. Now what's about this cot inverse x? In this cot inverse x, we can say it is, sorry, I have to take this one r, it's bigger, and therefore this is written as 0 to pi. And similarly, for the sec inverse x, I will take r minus of minus 1 to 1, and this is represented as your 0 to pi and minus of pi by 2. And similarly, what's about the cosec inverse x? Cosec inverse x is minus r minus 1 to 1. This is, we can say, this is equal to minus pi by 2 to pi by 2 and minus of 0. Start. Now students, briefly I have discussed about these intervals, and in the second part we also discussed the different standard angles and as well as the trigonometric graphical methods of sine and cos, because sine and cos are definitely sine x and cos x, or sine theta or cos theta are very important in the trigonometry. Here the intervals I can say briefly, because this interval is very important. Here in sine, closed interval minus pi by 2 to pi by 2 means this minus pi by 2 and this pi by 2 both values we include. Similarly, in cos inverse x, this is closed interval 0 to pi. So these intervals are very important. If a and b are two real numbers, and if any angle, that angle we can say theta, greater and equal to a and less than equal to b. Or if you think that it's very difficult for this theta, you can take any notations. X is greater and equal to a and b, or this is represented as a to b, and this is called, we can say, a closed interval. What's about the open interval? Open interval is represented by a is less than x and b, i.e. this is represented as like this type of notation. Here remember, this both having greater and equal to and less than and equal to, when they are equal to, then it's a closed bracket. And similarly, when it is only greater or less than, then it is represented by small bracket. And what's about the semi-open or semi-closed? So at this time we can say that a, suppose x is greater and equal to a and less than b, and it is represented at a and b, or a is less than x and greater than x and less than or equal to b, is represented as a and b. Now this is the most important factor, that this is the representation of this big bracket and this is our small bracket. Here also this is my small bracket and this is the big bracket. Big bracket represent equal to sign. Remember. Okay, thank you very much, students. Next time we get the second part.